Hey guys, it's Mr. Walker here. Thank you for joining me for another math lesson. And today I'm just going to kind of jump into things, right? Because we got a lot of stuff to cover, and I don't want to take up any more time than I have to from you guys. Because I've been told I have a tendency to ramble. The other day at a staff meeting, we were actually talking about math and how excited I get about math, and I tend to just ramble on about it forever and ever. And I said, it really comes from when I was young. I had a love for math, right? And every day walking to school, uphill both ways through the snow, carrying my brother's backpacks. They didn't want to go to school, but I wanted to because I wanted to learn about math. And I always remember my teacher, Mrs. Smith, would always do these awesome math lessons, and we had a great time. Whether it was adding, subtracting, multiplying, dividing even, we would always do such great things, and I look forward to it every day. And I think that's where my love of math stems from. So when I tend to ramble on about things, it's not really a malicious thing. I just kind of keep going. And then, we changed subjects for a little bit, and we started talking about
6.5 hours later.
and then so finally the dog looks up and says, "No, that's my latte." And we all kind of laughed out loud, had a good time at that. But anyway, I digress. We got a lot to get to today, so we're just going to kind of jump into it. So in today's lesson, what we're going to be talking about is we're actually going to be connecting some ideas that we've learned in the past from previous lessons to some new ideas and some new concepts, and kind of seeing how we can, learn new strategies, new pathways to solving bigger and bigger problems, because we've been looking at multiplying decimals by single digits and a little bit of double digits, but now we're going to look at decimals times double digits and even times other double digit decimals. So we're going to step up our strategy, step up our game a little bit here, and see some new things. So what I want you guys to do is make sure you have something to write on, something to write with. As you can see here, I have some graph paper. If you have graph paper handy, great. It'll help out when we're drawing some boxes and stuff. At least I feel it helps me because I can keep my lines straighter and stuff like that. But if you don't have it, it's not a big deal. Just paper or your dry erase board or whatever will work just fine. So something to write on, something to write with, and just be ready to follow along with me. All right, so we're going to start by taking a look at an example here of 21 times 5, okay? And there's a lot of different ways that we can solve this example right off the bat, but we're going to start off by thinking about this mentally. So using mental math, what's like an easy way we can solve this problem? Well, I would think of this right off the bat as solving it like 20 times 5, right? I could take it 20 times 5 plus 5 more, right? I could use those benchmarks like that lazy step that I like to take, right? To get 20 plus, times 5 first, and then I can add on 5 more after that, okay? If I was going to represent that with a tape diagram, what might that look like? If I was going to actually draw out that 20 times 5 plus 5 more, what would that look like? All right, so again, I could think of this as 20 times 5 plus 5 more. So if I was going to draw a tape diagram to represent this, I could start by drawing some boxes to represent my 5s. Okay, so there's 5, here's 5. I want to draw them about the same size and shape because they're all representing 5, right? And then I don't want to sit here and draw out 25, so that would take me forever. So I'm going to draw this like longer box and put in my ellipses there. That kind of is like saying we're going to get to 20, okay? So this is representing the rest of the 20. And then I would want to draw 5 more at the end. So this would be my 20 times 5 here, and then my plus 5 at the end here, okay? And altogether, that would give me 105, because 20 times 5 would give me 100, plus 5 more would give me 105, okay? So this represents here my 21 5s, which is equal to 105, okay? Easy enough. But let's stretch our thinking a little bit here. Let's try to take this a little bit further and see what else we can come up with, what other ways we can think about this, okay? So in this, we chose 5 to be our unit, right? We were thinking about 5 20 times and then another 5 more. So each one of these boxes represented 5. That's the unit we were sticking with. So let's imagine the area that those 5 would take up, that unit 5 would take up. So think of it this way. We have 1, 2, 3, 4, 5, right? So here are 5 boxes. 1 times 5 would be 5. So that's my unit of 5 right there, okay? So now instead of drawing it horizontally like we do on the tape diagram, I'm going to represent this vertically, right? Represent them as like rows of 5, 21 5s, okay? So hang with me for a second. So we can say that this is 1 5, okay? And I need 20 more 5s. Okay, so I have my one row of 5 here, and then I'm also going to drawing a couple more rows of 5, so 5, 10, 15 basically, and then I'm going to get all the way up to 20, okay? So this represents my 25s, okay? This is my 1, 5, and my 25, so if I combine those together, I would get my answer of 105, okay? There's so many like squares and stuff involved in this, right? So as helpful as this would be to stack it this way, I don't have time to sit here and draw out these squares. There's just so many units, so many individual squares to draw in. So instead, another way I could draw it is just representing those squares, those rectangles, visually without having to draw on each individual line. I'll show you what I mean by that. We can use an area model like we've used probably in previous grades. 3rd grade I know for sure, and 4th grade. I could just do like this. I could represent my 1 times 5 here. Okay, I could say this is worth 5, right? 1, 2, 3, 4, 5. Oops, I actually drew in too many, so we'll kind of cross that guy out. So this could be my 1 times 5. And then I could draw another rectangle here. To represent my 20, right? So now I could do 5 times 20, which would give me 100. 5 times 1, which would give me 5. 100 plus 5 would give me 105, okay? See how this is starting together? Just different ways that we can kind of represent the same thing, okay? It's not necessary that I draw out all 3 of these every time that I solve a multiplication problem, but they're just different ways that I can think about the same problem to help me get to that end goal, to help me get to that final product, okay? I could draw it using a tape diagram to think about the different units that I'm multiplying and how many times I'm multiplying it. Or I could draw out my square units this way and stack them vertically. Or I could just think of it abstractly as kind of like these shapes here. So we have some choices when we're solving problems. Let's take a look at another example and see if we can start to see the similarities and differences between these type of strategies. Okay, so this is where we step things up, take it to the next spot here. And we're going to look at some double-digit multiplication, okay? So, for example, let's say I had 23 times 31, okay? That's going to be the problem that I'm starting with here. That's going to be what I'm trying to solve. 23 times 31, okay? And I'm going to represent it. I'm going to use the same strategy as I used previously. I'm not going to draw on each individual unit. I'm not going to use a tape diagram. I'm going to use what's called the area model and just draw my rectangles to help me kind of break apart and distribute these numbers evenly, okay? And what I mean by that is I'm going to decide upon which number I want to use as like my unit value. What am I going to be counting by? Am I going to count by 23 31 times, or am I going to count by 31 23 times? Either way could work. You're still going to get the same product. It's just about preference and what works best for you. So for my sake of things, I'm going to count by 23 31 times because I know I can count by 23 30 times and then one more time, okay? And that'll give me my answer. So what I want to do is I want to think about that, first of all, that 23 one time. So I would say that that's 23, okay? And this is the one time. And then I'd also have to do that 23 again. I have to do it 30 times. Okay, so I can multiply these two numbers to get my product, to get what I'm trying to find out. And actually what I'm getting here are called partial products. It's part of the answer. Then we're going to have to add them up to get the final product, okay? So 23 times 1, I could do that easy enough. That's going to be 23. Then I'm going to do 23 times 30. So let's see, I could do 23 times 3. 23 times 3, which would give me 3 times 3 is 9. 3 times 2 is 6. And I'm going to put my 0 on the end, so that's going to give me 690. So I know that 23 times 1 is 23. 23 times 30 is 690. So now I could add those two numbers up. 690 and 23. And I will get 713, okay? So this area model helped me to not only break apart my numbers, but also to make sure that I'm distributing it properly. I'm doing 23 times 1, I'm doing the 23 one time, and I'm doing the 23 30 times, okay? Now, if I wanted to check my math here, just to make sure that this strategy is right, I could use a standard algorithm, right? So I could do 23 times 31, okay? And it would give me, 1 times 3 is 3. 1 times 2 is 2. Then I'm going to put my 0 here because I know I'm multiplying by the tens now, so everything's going to have a 0 on it. So 3 times 3 is 9, and 3 times 2 is 6. Ooh, would you look at that? These numbers are kind of lining up to what I have here in my partial products, aren't they? So now I can add these up. 3 plus 0 is 3. 2 and 9 is 11. 713. So I used the standard algorithm, still got the same answer, okay? Still got the same thing, which is great. So I know that any of these strategies will work, but the area model can definitely help show me what's going on behind the scenes here. I'm making sure that I'm multiplying 23 times 1, 23 times 1, and then 23 times 30. 23 times 30, okay? So keep that in mind as you're going through and you're taking a look at this strategy, all right? All right, let's do one more example together, see if I can get your head spinning a little bit here. And I'm going to throw at you guys a 3-digit by 2-digit number, okay? 3-digit by 2-digit problem, and let's see how we can do with this one. All right, so let's say this time I had 343, and I wanted to multiply by 21, okay? So I have a 3-digit number and a 2-digit number, okay? So right off the bat, I'm thinking I'm going to count by 343 21 times, okay? Because I could split that into a 20 and then a 1. I could split the 343. It's not going to hurt. I could do it the same way. It's just going to take me maybe an extra step, or I have to think about it a little bit differently, where this way I could just do like so. Well, wait a minute. What am I doing this for? Let me have you guys have a chance. If we were going to do 343 21 times, how would we label our area model? What would we represent that as? Okay, it might help you to think of it this way. So I'm going to think of this as a 20, right? My big area is going to be a 20, and then this is going to be 1. That's how I would break up that 21, times 20 and then times 1. And I would write my 343 at the top because that's what I'm going to multiply by my 20 and then by my 1. So thinking about that, 343 times 1, well, that's going to give me 343. Cool. 343 times 20. Whew, that's a trickier proposition, but I think we can handle it. 343 times 2 will give us, well, let's see, 2 times 3 is 6, 2 times 4 is 8, 2 times 3 is 6. So it's going to give me 686, but I multiplied by 20, not by 2. So it's actually going to be 6,860. So I have my two partial products. Now I need to add them together to get my final product. So I will do 6,860. I'm going to multiply that or I'm not going to multiply it, I'm going to add it to 343, and we will get 7,203. Now if we were to check this with the standard algorithm, we're going to see the same thing come up. We're going to get the same answer. It's just a different way of solving this problem, a different strategy that we could use. So what I want you guys to do is to try this out a little bit on your own today. You'll get some problems that you're going to practice this with. If you want a few more examples, or if you want to go through some of these together, please reach out to me. Let me know. I'd be more than happy to help. But again, as always, I appreciate you guys for watching and hanging in there with me, and I look forward to talking with you soon. All right, thanks.